Hello, in this presentation I'll be describing how our first practical should be conducted and going through some of the calculations. In this practical exercise we will be trying to find the concentration of a hydrochloric acid solution. Now, what we'll be trying to do is we'll be trying to create a primary standard solution using anhydrous sodium carbonate. So switch the electronic balance on and then put the dish or some sort of container on the electronic balance. What you'll obtain is the mass of the container or the dish that will be holding the sodium carbonate powder. And then I'll press the TARE button, and that'll set the balance back to 0. Then I'll place the powder on the dish or whatever container you're using. And in this case, I get a mass of 13.25 grams. And then what I'll do, I'll prepare the solution. So I'll take the solid and I'll place it in a volumetric flask, a 250 milliliter or 250 cubic centimeter volumetric flask. And I'll fill it to the mark. I'll fill it with liquid, with distilled water, and I'll create a 250 ml or 250 cubic centimeter solution. And the number of significant figures is in fact 4 in such a case. So I'll consider that to be 250.0 cubic centimeters, where that last 0 is the uncertain digit. Now, the mass of the sodium carbonate was 13.25 grams. The molar mass of sodium carbonate, well, that's 106 grams per mole. So the number of mole, mass divided by molar mass, is 0.125 mole of sodium carbonate. Now the concentration of the carbonate, well, that's the number of mole divided by the volume in litres, converting the milliliters or cubic centimeters to litres. And the concentration is 0.500 molar, mole per litre. Now, before you continue, it's really, really important to make sure that you've shaken that volumetric flask really well. Put the top on it, give it a good shake. Make sure that all the sodium carbonate solid has been dissolved. But after you've done that, you'll get a 20 ml pipette, and you'll extract a 20 ml sample. But let's have a closer look at what's going on. So you'll remove the solution, 20 ml of that solution, using the pipette right up to that 20 ml mark. But that's actually 3 significant figures, the uncertain digit being that last 0. So the volume is to be considered to be 20.0 mil. And then you'll transfer that 20 mil sample or aliquot to a conical flask. Then what you'll do is you'll fill the burette with the hydrochloric acid solution of unknown concentration. Now the initial volume is noted, and in this case, in this example, it's 10.0 mil. Some methyl orange is added to the conical flask, just a couple of drops. And what you'll see is a colour change. And what you'll see is a change of colour. The solution should turn yellow because it's basic. The pH is above 7. And then you'll proceed to slowly add hydrochloric acid to the conical flask. So turn the tap so the HCl flows into the flask. And you'll continue to do that until you see a colour change. Stop adding hydrochloric acid to the conical flask when you see the change in colour permanently occur, and when the colour of the solution is a soft orange or tan colour. If the solution turns a deep orange or red, you've added too much hydrochloric acid. So it should turn a soft pink or tan colour, not a deep orange or red. The colour change indicates the end point of the reaction has been reached. The final volume is noted. In this case, it's 33.5 mil. That means that 33.5 minus 10, the initial reading from the burette, 33.5 minus 10, which gives me 23.5, that's the amount of HCl solution that was added. The titer is said to be 23.5 mil. So the carbonate reacts with the acid and it produces salt, carbon dioxide and water. Now, I added 2 in front of the NaCl to balance out the sodiums. There were 2 sodiums on the left. Now there are 2 sodiums on the right. But I think the hydrogens do not balance. There's only 1 hydrogen on the left and 2 hydrogens on the right of that chemical equation. But that's easily balanced. I just add a number 2 there in front of the HCl. I've also included the states. So now I've got a balanced equation. The ratio of mole of sodium carbonate reacts to the mole of acid. That ratio, that stoichiometric ratio, is 1 to 2. The number of mole of hydrochloric acid reacting is 2 times the number of mole of sodium carbonate that reacts. So that equation is wrong, but I've just corrected it. It's 2 times the mole of sodium carbonate gives us the number of mole of HCl. Let's work out the concentration of that hydrochloric acid solution. There's a formula that might come in handy. The number of mole is equal to the concentration multiplied by volume. So that's the equation that I showed you previously. Now, I know the concentration of the sodium carbonate, that's 0.5. I know the volume of sodium carbonate in the conical flask, that was 20 mil, or 0.02 litres. And I'm timesing it by 2, and that should give me the number of mole of hydrochloric acid, which is equal to the concentration of the acid multiplied by its volume. Well, the titer was 23.5 mil. Converting that to litres, that's of course 0.0235 litres. I've got one equation and one unknown. The unknown is C, the concentration of the acid. And the final calculation that I get, to 3 significant figures, for the acid, the concentration is 0.851 mole per litre. Well, that's how you do the prac, and that's how you perform the calculation. Hope you enjoyed watching this presentation.